Hello everyone. Today we are presenting our final project. We are group of three, and my name is Aishwarya Dekhane, and I did a data collection part and defining model architecture. The other two will introduce themselves.
Hello everyone. My name is Atharva Pore, and I was responsible for data preparation and model training in this project.
Hi everyone, my name is Shubhang Vangari and my responsibilities for model training and model evaluation.
Okay, we'll start our presentation. I'm sharing my screen. So I'll be presenting our project titled Deepfake Video Detection. First, we'll introduce. Deepfake technology leverages artificial intelligence to generate highly realistic yet fake videos, creating opportunities in media and entertainment, but raising this a big issue for security when misused. So these manipulated videos can serve misinformation, deceive viewers, and compromise personal and national security. So our project addresses this challenge by employing advanced machine learning technique, including CNNs, to build a reliable detection pipeline. Next is the problem statement. Our problem statement is divided into three parts. First is the misinformation. Deepfakes have been weaponized to spread false information, manipulate public opinion, and create deceptive content. These fake videos can underdetermine public trust. The second is detection challenge. The rapid advancement in AI make detecting deepfakes increasingly difficult. They are designed to mimic real content with such a precision that traditional detection methods often fail. Lastly, is security and privacy. Deepfake compromises individual privacy, enable identity theft, and national security. Their misuse has far-reaching consequences from personal harm to large-scale political manipulation. This is why we need an advanced detection system to address these critical challenges. Objective. Our objective is divided into main two parts. The first is to develop a robust detection system. This involves using state-of-art machine learning technique like CNNs and facial landmark detection. These methods allow us to detect deepfakes with high accuracy by identifying uh, minute subtitle in video content. The second is to enhance media integrity. By mitigating the impact of deepfakes, we aim to compact information, protect privacy, and restore public trust in digital media. This project is not just about technology, it's about ensuring the ethical and security use of AI. The next part will be explained by Shubham.
Thank you, Aishwarya. That gives a good understanding of the problem statement. So going ahead with the implementation of the project idea would have been really impossible without the clarity that I gained from the literature review. I read a few papers, but the last two papers stand out. These last two papers, which is the Mesonet and the deepfake detection using RNNs, helped devise an overlaying understanding of the overall project architecture. Aishwarya, could you go to the next slide, please? Thank you. So here we have the methodology. So once the video is uploaded to the deepfake detector, right? Each frame is extracted and sent to both the models, and we have used two models over here, VG16 and Inception V3. So that is the first part how we tackle the problem, that is frame extraction. Then we move to the model architecture. So as I said, we have used two models. One is VG16 and Inception V3. VG16 was used as it has high parameter count that helps retain more features, but the downside of this is that it was very resource intensive. Inception v3 was used. It has very fewer parameters, but it is not very resource intensive, and it is computationally very efficient. So a combination of these two models helped pick up a lot of features and also with very less training time. Once we have both the predictions from both the models, the predictions are combined using a weighted average approach. This weighted average approach shows a unique combination of both the models, as we rely more on VG16 for picking up a lot of minute details, while Inception Net picks up the spatial differences. Going ahead with the next slide, I'll be explaining more about the implementation. Aishwarya, the next slide, please. Thank you. Yeah. So both the models were trained over 50 epochs. Both the models, the optimizer that was used was Adam, and the loss was set to binary cross entropy, as the task the models were being trained on was binary classification, that is real and fake images. The data set was also having two folders, train and test. Within them, it was fake and real image again. Once the model was trained over 50 epochs, the last model was saved along with the best 30 models. A combination of all different models was used to understand which model with Inception and which model with VZ16 gave us the best combination of accuracy. The parameter in check for saving the best 30 models was validation accuracy. Moving ahead to the final part, once the predictions were available, the weighted average approach was used to combine both the predictions, and 70% weightage was given to VG16 model, and 30% weightage was given to Inception V3. What this means is that once we send an image to the detector, predictions from VG16 and Inception net are combined using 70:30 ratio, and the output is predicted. More about the results is given by my friend Atharva.
Thank you, Shubhang. So let's dive into the classification report. So this is our classification report, which shows our model's performance in identifying fake and real videos. With an overall accuracy of 82%, the model achieves a slightly higher F1 score for real videos, which is 0.83, and as compared to the fake ones, which is zero point 0.8. It indicates the strong balance between the balance between performance across both classes. Moving ahead to the next results. This is the confusion matrix which visualizes our model's predictions against the actual labels. The model correctly classifies 46 fake videos and 56 real ones, with some misclassification of 14 fake videos were predicted as real and 9 real videos were predicted as fake, reflecting an overall strong performance. So this is our confusion matrix. Let's proceed to the next outcome, which is the ROC curve, which demonstrate our model's ability to distinguish between fake and real videos with the AUC value of zero point 0.9, which indicates high classification performance. The curve shows a strong trade-off between the true positive rate and false positive rate, which validates the model's robustness. Moving ahead to the next finding. So this is the precision recall curve, which illustrates the trade-off between precision and the recall, which is the accuracy of positive prediction and the ability to identify all true positive for a classification model. The curve helps us to evaluate the model's performance, especially in the cases where the data is imbalanced, and it highlights how well model balances these metrics at different thresholds. Moving ahead to the next slide, I will demonstrate which challenges we encountered during this process. The first and foremost is the data imbalance. So our database initially had a heavy skew towards real videos, which could have led to model bias. To address this, we applied data augmentation techniques such as flips, rotations, and color adjustments to balance the training set and improve its diversity. Second is the computational constraints. Training on the DFDC data was very computationally demanding for us. To manage this, we utilize mixed precision training and leverage the power of 8 NVIDIA RTX 4090 GPUs, which we rented out, which allowed us to significantly cut down training time without compromising the performance of our model. The next is the integration complexities. Integrating optical flow with CNNs posed us challenges because of the differences in the different data types. Through the iterative testing and refining our model pipelines, we ensured smooth integration. Ultimately, we improved the model's overall functionality. And the last is the team resilience or adaptation and resilience. Despite all these challenges, our team remained adaptable, and here we are presenting our final project demo. So we learned valuable lessons throughout this process, which not only strengthened our skills but also drove our project forward. So moving ahead to the impacts and results. So we have drawn two main impacts. The first one is the real world applications. In the media, this technology can ensure content authenticity, helping to protect public trust. In the field of security, it can be used to verify video evidence for law enforcement, and in legal cases, it will play a very crucial role to ensure the reliability of digital evidences. The second is, as Aishwarya said, combating with misinformation nowadays is very important, and our system is designed to detect the manipulated videos, which can help prevent fake news from spreading. This will also support platforms in stopping large scale misinformation campaigns. Ultimately, this technology holds crucial value for maintaining trust, security, and legal integrity in our increasingly digital world. Moving ahead with Shubhang will explain you guys the future scope of our model.
Thank you, Atharva. The future scope of the project of the problem is my bad. The future scope of the project is we are going to develop an audio processing signal pipeline, which is going to help us detect if the audio signal is a fake audio signal or real audio signal. Once we have the entire audio signal pipeline ready, what we're going to do is we're going to combine the current pipeline, which is a deepfake video detection pipeline, along with the audio detection pipeline. The outcome of that would be we would be able to get an understanding if the entire video which is uploaded to the deepfake video detector is authentic or not authentic, or if it's having parts of stitched real content and parts of stitched actual content. They should give us an understanding of what part of the video is real, what part of the audio is real. This is a big picture of what we want to do in the coming semesters, but for now, we are happy that we implemented the deepfake video detection pipeline. Moving ahead, next, I'll be sharing my screen and I'll be showing a demo of the project. Thank you.